All right, my Algebra 1B class. This is Module 11.2, or two-way frequency table. Okay, so in other words, pretty much what that is, it's a table, which we have right here. Okay, that has two categories. Okay, and within those categories, so in this case, we have employed, unemployed. We have the frequency of which something occurs within those two categories. All right, and we can call those subcategories. So within the employed and unemployed categories, we have a subcategory, juniors and seniors. All right, so we're going to go over that. How to construct one and how to read one and interpret it. All right, so follow along with me. A two-way frequency table which is also known as a joint frequency or a contingency table, right? Because how much something occurs or the frequency, and that's supposed to be a G, the frequency or how often something occurs is contingent or depends upon something else, another variable. Okay, so two-way frequency tables are used to display bivariate categorical data. Okay, so you can put it here or you can put it down here. Same thing. It's a little typo there. Okay, so a two-way frequency table also shows the frequencies, and it's supposed to be a Q, their frequencies of data from a survey or experiment classified according to two categories. And look, that's exactly what we have right here. We have one category of employed, second category of unemployed, okay? So we have our example down here. Now, so let's get to our first example question. It says, what are the subcategories of the table? Okay, well, we just went over it. The subcategories of our table are juniors, okay, and seniors. Juniors and seniors. Okay, so in this specific case, okay, we have juniors and seniors within high school, and we want to know, out of those juniors and seniors, how many of them are employed, which is our main category, and how many of them are unemployed, okay? So the total amount of employed juniors are 8, okay? And then the total amount of seniors that are employed are 15. Okay, so within the employed category, culminating of both junior and seniors, total amount that are employed are 23. Then we combine both the junior seniors that are unemployed in our other category, and the total amount of them are 22. Okay, so reading from left to right, we see that the total amount of just employed and unemployed juniors is 20. Okay, so then we read another way. The total amount of employed and unemployed seniors are 25. So as you notice, we can read it both ways, okay? That's what's called two-way. We can read it this way for the two categories, or excuse me, subcategories, right, vertical. We can also read it left to right, right? And this is mainly of the main categories for one particular subcategory. So in this case, the one particular category that we're reading for are both employed and unemployed is just juniors. So we're reading for only the juniors that are employed and unemployed. Going down, or excuse me, going across to the right for our other subcategory, how many, or the total amount, the total amount of both of seniors that are employed and unemployed is 25. Okay, so we can read it two different ways. All right, moving on to our next category of type of frequency tables. Joint frequencies are the values for every combination of subcategories. In the table above, 8 is a joint frequency that represents the number of students who are employed, right? We just went over that, just for juniors, okay? Our next term, marginal frequencies, are the totals Okay, and that's a typo. Total is actually supposed to be here, so you don't have to worry about that. Marginal frequencies are the totals of each subcategory. Okay, so according to the frequency table above, 20 is the marginal frequency that represents the total number of juniors. Okay, so in other words, altogether, both employed and unemployed, their marginal frequency is the amount of juniors that are both employed and unemployed. And the amount that are both employed and unemployed, or the two categories, is 20. Okay? All right, so check. It says use the information given to fill in the missing data in the two-way frequency table below. Okay? All right, so let's do that together. Okay. It says names. Unisex names are names often used for both males and females. At one point, the most common unisex name in the United States were Casey and Riley, with 176,544 Caseys and 154,861 Rileys. Okay, so in other words, kids that were named both Casey and Riley were these numbers at a given time in history of the United States. During that time, there were 104,161 males with the name Casey and 75,882 females with the name Riley. It says organize, so this is our main objective. We want to organize the data in a two-way frequency table, okay? So let's just review real quick. Remember, we have our two main categories. Our two main categories are, in this case, the names of kids with the name Casey and Riley. That's our two main categories. Then the subcategories of these names are the amount of kids that are males with that name, with these given names, Casey and Riley, and the amount of kids that are females with the given names, Casey and Riley. Okay? So now we just got to take that data and we got to add it up. All right. So if we looked up here above, okay, all we got to do is fill in the missing information. Okay? So to find the missing information of females, so let's do the first one. To find the amount of females that were named Casey at a given time in the United States, all we have to do is take the difference between our total amount of both males and females, because remember, this is a total of this category. So this total includes all the kids, both male and female, that were named Casey at a given time. So to find the amount of kids that were females named Casey, we just got to find the difference between the two. So the difference between the two, I'm just going to subtract. I'm going to take 176,544, okay? And I'm going to subtract the amount of males, which is 104,161 kids, okay? So the difference between these two numbers will give me the amount of females that were named Casey. So 176,544 minus 104,161 gives us 72,383. So this difference, this answer right here, gives us the amount of females that were named Casey at a given time in the United States. Okay, so that's our first one. All right. Now we got to find the amount of males that were named Riley at a given time in the United States. So the same thing as we did for Casey to find the females, we're going to do the same thing for kids named Riley that were males. So we just take our total, and from our total, we're going to subtract the amount of females that were named Riley. And that will give us the amount of males. That's what we're solving for. Okay, so I'm going to put a question mark there. You don't have to put the question mark there. I'm just putting it there because that tells us that's what we want. All right, and I'm going to do a different color. Okay, that way we have everything separated. So now we're solving for Riley. So this is Casey. And now, just to make some organized, we're going to do Riley, and I'm doing a separate color. Riley. All right. All right, so now we're going to take the total, 154,861. And we're given the amount of females. So the amount of females named Riley is 75,882. And we just want to find the difference between the two. Okay. 154,861 minus 75,882. Okay, using my calculator. Okay. gives me, let me make sure I have this right, 78,979. Okay. And let me make this a little thicker so we can see. All right, so now I can erase this. So the amount of males named Riley, by taking the difference between the total amount of kids, both male and female, and subtracting the amount of females named Riley, we can find the amount of males named Riley at a given time in the United States. So I'm just going to write that into my box or into my table. 78,979. Okay? Now, to find the totals, all we have to do is just add the difference between these two, okay? I don't have much space here. So, using your calculator, you're just going to add these two numbers, and that'll give you a total, all right? Okay, so for the amount of males that had both of the names, Riley and Casey, okay, we have, if I add these two numbers together, these two right here, I get 183,140. So remember, all I did was find a difference between these two numbers. That gave me the amount of females. Okay? Same thing here. I found a difference between these two numbers. That gave me the amount of males that were missing. Okay? Now I'm going to read the other way. Two ways to read it. Okay? So now I'm going to read the other way. All right? So now I'm going to add the amount of females, okay, for both Casey and Riley. So I put a plus sign here. And that'll give me the total of females that were named Casey and Riley. So 72,383 plus 75,882, okay, gives me 148,265. Okay? Now, the other way that we're going to read it. First we're reading horizontal from left to right. Now we're going to read going down to find the total. So now to find the totals of all the kids, both male and female, named Casey and Riley. Okay. Now I got to add these two numbers together. Okay. So I'll put a plus right here. Plus there. And I'm going to use a different color. Why not? We'll use green. So now I want to find the total between these two numbers. Okay. Right here. So now I'm going to take 183,140 plus 148,265, and that will give me a total of 331,405. Now, guess what? I'm sure you might have noticed by now. We can either add these number totals up vertically, right, this way, or the second way, hint, hint, second, two-way, right, two, we can add these two numbers up from left to right, and we'll get the same thing. If I add 176,544 plus 154,861, I will get the same answer, okay? So notice that's how I call a two-way frequency table, okay? All right, so now we're going to move on to the next page. Remember, if you need to stop or pause this, if I'm going too fast, you can stop and pause this, slow it down, and see where you messed up at. Okay, so we're going to go to the next page now. All right. So it says, check. You're going to make your two-way frequency table using the data below, okay? So this is for you to do. This is your work, and this will be for a grade. I'm going to check that, okay? All right. We're going to move on to the next thing. All right, let me make sure I have this correct. All right, so now we have a new term, relative frequency tables, okay? Remember, the term relative has to do with the relationships, right? Something is effective in relation to something else, okay? Say, for instance, when you can compare how fast someone is, okay, you won't compare Usain Bolt or I forgot the other female runner's name, Olympic runner. But you won't Shakira, I think it's Shakira Jackson or Shakira Johnson, whatever her name is, okay? You won't compare her to maybe a middle school runner, right, who hasn't really competed at the same level as her, Okay, her speed might be relative to other Olympic female runners. Okay, or let's say, for instance, a car. You're not going to compare how fast a muscle car goes in relation to a luxury car or sedan because they're two different class cars, right? One car is made specifically to go fast and race, where another car is made specifically to carry a lot of people or cargo. So they're going to be in two different categories. So it's relative. The way you compare things is going to be relative. So that's the same thing with our frequency tables. Okay, a relative frequency table is it's a relative frequency. Okay, so you should be filling this out. A relative frequency is the ratio of the number of observations in a category to the total number of observations. All right? Remember, whenever you think of ratios, okay, think of a relationship comparison or fraction, okay? Usually when we think about ratios, let's say we have like a 1 to 2, something like that, okay? This is example ratios, right? Or a 2 to 1, okay? 2 to 1, or half, right? These are what we call ratios. So just think of it that way. Okay, so fill in the next part. A joint relative frequency is the ratio of joint frequency to the total number of observations. And think about joint. Joint is usually when something's connected or joined together, right? Like a joint between your bones, right? You have a socket and you have a joint that rotates within that socket. It's connecting something, so just think of joint that way, okay? So a two-way, okay, so now a two-way relative, and actually I'll put two-way here. We'll have it in one place. So a two-way relative frequency, right, the amount of something occurs, table, or a joint relative frequency table can help you see patterns of association in the data, okay? So in other words, when we look for patterns, okay, or an association, that means one depends on the other, right? You're going to have a relationship between something. Something is affected by something else, right? There's a pattern, okay? So a two-way relative frequency table, to create a two-way relative frequency table, you divide each of the values by the total number of observations and replace them with their corresponding decimals or percents. Okay? So keep this in mind. You divide each of the values by the total number of observations and replace them with their corresponding decimals or percents, okay? So it says the total values for every combination of subcategories in a two-way relative frequency table are called joint relative frequencies. The joint relative frequency represents the ratio of the joint frequency and the total number of observations, okay? All right, and then our last term, make sure I have this right. Okay, so it says, and give me just a second, I'll make sure I have this right. So a conditional, so our other type of two-way frequency table, or relative frequency table, a conditional, okay, so a conditional relative frequency is the ratio of the joint frequency to the marginal frequency, okay? So in your last one, we'll just get started on the last one. And give me just a second. Let me check my data correct. Okay, so now let's go through this. go through the steps. Okay. So for your exit ticket, it says consider the two-way frequency table, which shows a person's frequency, or excuse me, which shows a person's preference for winter or summer and whether they are a teacher or student. Then it says create a two-way relative frequency table. All right, I'm gonna help you get started in the first one. Okay, so it says first, organize the data in a conditional relative frequency table by age group. Okay. Now in this case, we're not gonna have age group. We're going to organize it in terms of students and teachers. Okay, so we're gonna organize it in terms of students and teachers, and then we're gonna organize it within winter and summer. So look, part of that's already done for you. That's the first step. Okay, so we organize it that way. Then the second thing we need to do is, okay, we gotta divide the totals. Okay, so we gotta divide the totals of these elements right here. So once we divide the totals of those elements right there, that'll give us our percentages. We're gonna stop there, and then I'm gonna have another video down below going over that.